questions from scratch. Okay. And you will be more confident in working on the capstone project, and you can also add in your resume. Okay, so because what I see from the industry perspective, that if you have some of the areas where you can show the demonstrations, if you have some practical experience, and if you're adding it in your resume, so I mean the higher chances of being called for the interview. Okay, so the idea of this internship is again to upskill and to give you a safer zone where you can fly, right? So we'll set the context today, and we'll keep working on these on every weekend, and so that you will be aligned with what I'm trying to say. Okay, so let me go with this. The something called, before I talk about AIML, Gen AI, LLMs that you see on the screen, there is something called natural language processing. So the term NLP. Okay. So once I say NLP, it's a system. Its abbreviation is again natural language processing. Okay. So we are going to process something. What? Natural language. So we all are a human, right? We speak our own language. May not be English, maybe some other language. So these are some natural language. Humans have a tendency to speak the natural language. We all speak our natural language. So how the computer is going to process it? Computer is not going to process how you are going to speak. They need to change it into some other format. Okay. If I right now am speaking English, computer is not understanding English directly. There is a one layer. So what they are going to do, whatever I am speaking, they're gonna convert it into some numbers. Okay. So numbers is nothing but we call a term called embeddings. Okay. Just remember this term, embeddings. Nothing to worry about what is embeddings. Just remember it. It's like converting what you are saying, text into some numbers. So there are two terms that I will use in coming classes, something called vectorizations and something called embeddings. Only two things, just remember it. Because computer doesn't understand English. They understand in binary format, some numbers. So that is why you see on the screen the term called NLP, that is called natural language processing. So why I'm talking about natural language processing right now? Why not artificial intelligence? I'll talk AI later. Because the generative AI or agentic AI that we are trying to talk, their primary, you can say, the foundation stone is natural language. Okay. Because the bot that you are asking any questions is again a natural language and give you a response back in a natural language. So that is why NLP is something that you have to understand first, not like extensively, but at a base level. If you understood this concept NLP, then you are good to go and design this generative AI and agentic AI solutions very beautifully. Okay. So now there are two more terms on the screen. Something called, if you see this term, something called Gen AI. Okay. Now, what is Gen AI? But before that, there is one more term that we see is something called LLM. Okay. So what is LLM? You might have seen in the previous sessions, or maybe previous to previous sessions, speakers might have touched this LLM, large language model. Why not a small language model? Can anybody tell me what is difference between small language and large language? Just I'm pausing for 30 seconds. Anybody? Okay. So small language model is something which are trained on only limited corpus. The term that I'm using, a corpus, is nothing but a collection of sentences. We call it as a corpus. Okay. So large language model, when we call it a large language model, for example, if they have a trained on a vast number of corpus, vast number of parameters, okay, then we call it as a large language model. The models which have which I've seen in the entire internet, so to say, to understand at a high level, they have scrapped entire informations, libraries to libraries. Okay. So they have these huge repo of information is LLMs. Just think of it as a chat GPT. Okay. So chat GPT is LLMs. We call it as Cloud Code. We talk about Gemini. We talk about Grok. Okay. So these are LLMs. But what we call it, but what you think of when you talk about Gen AI? Okay. So before I explain Gen AI, let me switch to some screen. Let me erase it back. Escape or something. Let me have this. Okay. Undo. Let me come back. Escape. Let me share my screen again. I think it is stuck in somewhere. Just 30 seconds. Let me check my PPT first. Okay. Just share my screen again. Okay, my screen is moving, right? Okay. So now if you see this one, I mean, again, before I talk about Gen AI, these are the basic thing that maybe the speakers might have touched. And let me set the context here because it will help you also, because you people are maybe have not seen these the entire journey of how this data science are connected to Gen AI and agentic AI, and what is machine learning, what is the deep learning, right? So I mean, these things will make your concepts clear, and then you can understand Gen AI and agentic AI. Because if you are able to distinguish between this machine learning and Gen AI, then it will solve our purpose, because we will uh, clear about that where we'll apply this Gen AI and agentic AI concepts. Okay. So if you see this one in the left side, there is something called a word called, this artificial intelligence is written, and you'll see a lot of things are written here. And it's very maybe confusing for you that what is this, this speech, robotics, autonomous vehicles, everything is in AI, right? But how you're going to distinguish, right, in Gen AI, because there are a few things which are very interlinked to each other, right? But artificial intelligence is like a bigger umbrella, and there we have this machine learning, deep learning, generative AI, agentic AI, right? Don't worry about the definitions of generative AI and agentic AI for now, but here concentrate on this AI part. So when we say AI, artificial intelligence, so how you try to infer it, because something which that comes in our mind, that why we call it artificial intelligence, because humans have a natural intelligence, right? We have this reasoning power, and we try to perceive things, try to act, try to put reasonings on top of that, right? However experience we have, right? But when machine starts thinking on your behalf, right, mimicking your natural intelligence is called artificial intelligence, right? But how machine is gonna mimic? Because they need some data, right? Then only they will mimic, right? Otherwise, how they gonna mimic, right? Like a copying something. The humans, when you start copying humans' behavior, then it comes under artificial, intelligence. So, I mean, these are the huge cases where we see the usage of this artificial intelligence, but there are a few overlap. Okay. So on the right side, if you see, there's something called machine learning, right? So how machine is going to learn? We all human learns, right? How we all human learns? So if you think of like your childhood, parents teach you that how to behave, right? What to do and what not to, do's and don't, right? So somehow people are teaching us a new theory, new concepts. So a kind of a natural learning is there, coming from the environment where we all live, right? But how we are going to teach machine? So machine needs a data, historical data. For example, if you want to forecast it, for example, today in Delhi, rain will rain will happen or not. So that will come under forecasting. We are forecasting how the weather forecasting teams forecast weather for, let's say they have forecasting for each day. How? Because they have huge repository of historical data. Let's say they have a historical data of 100 years. And based on those 100 years, they are pretty much sure that today on 30th June at 6 p.m., the rain will happen or not, and how much quantity also. They are so much precise. So how they are going to do that? They are applying this machine learning logic, and based on that they have this data that okay, because of the data says so rain gonna happen. Possibly there are errors in that, but prediction, when we say forecasting, again there are plus and minus, but still we have some forecasting, right? Now there is a term called deep learning. So when we talk about this deep learning, right? So I mean, what we think of deep learning. So you might have seen some of the use cases of computer vision, right? So you might have seen people detecting some objects from a distant and identifying whether it's a target or maybe some of the people walking through, right? How they are doing that. So based on this deep learning, applying some of the neural network. So what is neural network? Neural network, I mean, at a high level, try to understand it as a something like a neurons, built on neurons. Neurons are nothing but it's collection of logics, gates, like AND gate, OR gate, you might have heard of, right? So neural networks decide based on the hidden layers. Okay. So these are the terms which may mislead you, but try to understand that where these concepts comes into play, right? So when you talk about this deep learning, so the neural network will come automatically. You might have seen a term, might have some of the, uh, speakers might talked about a term called transformer. Okay, a model called transformer model. So transformer model is nothing, it's built on top of neural networks. So neural networks, for example, we all have a brain, right? So brains are made up of neurons. And how neurons process the informations? One information passed to other neurons, and based on those neurons it goes on to different neurons, and then we put our reasonings, and then we put some logics, right? So neurons decides the outcome. Okay, the same way deep learning happens. The deep learning, these systems think of when they have these neural networks in place, right? And then this data science part, again, having those interfaces, that descriptive things that we typically do, a few algorithms, traditional algorithms we talk about, right? So these are the some data science stuff, right? But the something which we I need to talk about so that we understand this agentic AI also. Right now, I'm not focusing more on the agentic AI, but bringing you all on the same the floor, same page, so that you understand that in these coming weeks what we are going to touch and how we are going to proceed further, right? So something that I was talking about is natural language processing that I talked in the beginning, right? So we all speak some language that is a natural language, but computers are gonna understand only the binary format. So I mean, how computer is gonna process it? Because when you feed natural language informations to computers, they're gonna process it. How they're gonna process it? Okay, so again, when you say NLP. So it's a part of linguistics and having this computer science in place because algorithms are built using these computer science concepts only. Okay. So it is primarily concerned with giving computers what the supports and manipulate human language. Okay. So what kind of a task, if you have this NLP systems can do, for example, uh, there are some, the Alexa, you might have heard of Alexa, right? So you tell Alexa to play a Bollywood song, so they're gonna play. How? So you speak in a natural language, they transcribe it, they manipulate, okay? And then they give you a response back, kind of recommendations that, okay, these are the songs from 90s, 80s, 70s, right? So the natural language, something also we'll see in a Gen AI, something called machine translations, right? How machine is going to translate? You might have seen Google Translate. So it's a part of machine translations, right? So, I mean, how you're going to translate, right? So machine translation is again one of the transformer task, deep learning task, where if you have a source language, for example, let's say my mother tongue is Hindi, right? So my source language would be Hindi, right? And now I speak in English. So that is a target language. So same thing applies to you. If you have, let's say, mother tongue, a different language, that would be source language. And if you are creating a systems that can convert your mother tongue language to English, let's say it's a target language for you. So you will have to apply this machine translations from source to target. Okay. And you can build beautiful applications. For example, entire world doesn't know the language of each other. Is there any systems that you can put in place where if someone speaks, let's say, one of their native language, can be transcribed back into English so that people can understand, right? Isn't it, interesting one, right? So you need to bring in the few libraries, few pre-trained model, right? So the word I'm using very precisely is the pre-trained model, a model which are pre-trained. So the difference between machine learning and generative AI is only the pre-training of the model. The Gen AI concepts are built on pre-trained model. LLMs are pre-trained. Okay. What does it mean? For example, in machine learning, let's say if you are trying to build a system, so you need a data. So you will ask, let's say a company, just give me your historical data. They will give you historical data, and then you will create a regression algorithm, classification algorithm. For example, logistic regression you apply, random forest that you apply, let's say something like this. So you need data. But if you have some of the LLMs, you don't need their data. You just need to pass their data to your LLMs. That is the beauty of pre-trained model because you do not need to build things from the scratch. Okay. So that is a concept of this LLMs. Okay. So always remember that whenever you talk about generative AI, people are talking about only the pre-trained model. That's all. Okay. Now coming to this information retrieval, if you see how you're going to retrieve the information. So these are the applications of NLP. Okay. Again, you can do it with Gen AI or agentic AI. Okay. Something called sentiment analysis, information extractions, question answering. So something, can you do it with your chatbot? Yes, you can do it with your chatbot. That is called question answering. Okay. So any of the Gen AI concepts or agentic AI concepts are built on NLP, a transformer model, and neural network. These all three things you will see that will come into play. Okay, the basic concepts are all these three only. And other things that we'll see that will part of this, the systems that is the extra thing that we'll talk about. Okay. 1 minute, just give me 30 seconds. Okay, now there are three more terms which we will see, something called natural language generations. So when we talk about this natural language generations, okay, let me not use this one because it's create a problems. Okay, let me cross it. Okay. So something called natural language generations. There are three things here. Something called NLP that we talked about, and natural language understanding. So NLU, and NLG is something that we'll talk in this in the entire journey of this internship, because the Gen AI and agentic AI solutions somehow do these two things: generations or understanding. First they understand and then they generate, right? And also on top of that, NLP task you can perform. If you want to have this named entity recognitions, right? Past parts of the speech. These are the applications, the task that you can tell your, the chat bot that you will be building to give this response back, right? But something called generations. So generate what generative AI typically do? They generate a new content, right? So, I mean, whenever you ask any questions, a prompt or something, right? So they will generate new content for you. For example, if you're asking some finance related questions, they're gonna reply you back that, okay, what is the financial, maybe you can say the 12-month forecasting of some XYZ organization. So they're gonna give you a response, right? It's again a generating a new content. So generative AI is nothing but when you try to generate a new content, then we say it is a generative AI. Okay. But these are the three things it will always be there inside any of the Gen AI or agentic AI solutions. Okay. So these are the basic things that I'm talking about. 1 minute, my screen is not moving. Yeah. So I think this is not required here. It's a journey of NLP. But again, if you see how these are started, but I mean, the something that people have started with some of the translations way back in 1950, and then they moved to 1960, where we have some of the systems where, we call it as Elijah, right? It was a basic AI systems that was built. And moving to this 1970s, we have a semantic network, dependency theory. These are some conceptual, theoretical things people have started working to come here, like kind of coming to the Gen AI era, right? And also in 1980s, we have something called expert systems. It's more of a rule-based systems. For example, before AI or generative AI, we have systems called a rule-based system. So you might have seen people used to write a line of rules, right? So it was not something where AI was involved. If rules fails, your system gonna fail, right? Now, during 90s, we have some of the models, like some of the basic model, we'll say, that where try to solve some of the systems where, kind of a predictions, so to say, right? LSTM, there is a more term called, long short-term memory. Okay. So these are the terms that you need to understand first. Okay. Now, when we have these systems, right? Like a language modeling, the embeddings that I was talking about. Okay. So embeddings, when you talk about embeddings, so again, converting some words or some textual information into numbers. And then during this, this era 2020, after 2020, if you see this, these terms, attentions, you might have seen these terms earlier, transformers that I was just talking about, and these pre-training models. Okay. So I explained what is pre-trained model, that is already trained on the entire, the vast corpus. Okay. And attention mechanism is again predicting, the new sentences, right? For example, if I'm asking ChatGPT, so what they are doing, kind of predicting the next tokens in a sequence, but you see the entire paragraph. But the rationale behind is that what? They're predicting next tokens one by one, right? For that, you need transformer and attention mechanism, because they can also understand long context. Now, try to understand when I say long context. we all are humans, right? If I give you an entire, let's say, 10-page paragraph and I tell you to understand within 1 hour, you may struggle. If I tell you to give a summary, you may fail. So you may not understand the longer context. The same thing happens with Chat GPT. If you put them, let's say, 1,000 documents, they're gonna hallucinate. Factually incorrect answer they will give you. A term I'm using right now is hallucination. Okay. Hallucination means you might have seen a people calling that he is hallucinating. Means a system when start giving you factually incorrect response. For example, if you ask ChatGPT what is the capital of India, if they start saying it's Paris, isn't it a factually incorrect answer? Yes. So it means your AI system is failing, your AI system is hallucinating. So that we'll see. But again, this transformer attention mechanism is something came into the market because they start understanding the longer context. They start understanding the longer conversations, the gossip, right? We say gossip, right? People do a lot of gossips, right? They understand entire stories, right? So the same thing that I'm talking about, that Chat GPT, if you put them the longer context, they will understand. The reason is that they are built on top of transformer and having this attention mechanism, right? That is why they understand huge context. Okay. Now, after that, we have a different GPTs like Chat GPTs, Claude Code, Gemini, a lot of LLM models that we see. And even if you people use it for your now, like creating your, maybe the assignment and everything you built using this Chat GPT only, right? So, I mean, in my era, we don't have anything like this, right? So, I mean, there's something that you need to also focus on how you use this AI, the chatbot, or say to say AI tools, that how you use it responsibly, not to use it for like offensive behavior, not to have those, just to put, just to take responses from the, this AI tools, but also see that how responses are, try to understand it, because not to have, not applying your brain is also like, not good for people, like, making the AI tools also making slave, right? Not to become slave of those AI tools, right? So these are the terms that we will talk about also. Why I am showing these slides is because the base of the GenAI agentic AI systems will be built on these concepts, like a transformer models that I am talking about. Okay. I talked about the, the at high level, that why this transformer model or this attention mechanism is, important for us. So when I will be explaining any of the chatbot, how I have built, and we all people will build, and I'll explain that, how this agentic and generative AI solutions will build in coming weeks. So you will understand that okay, it is built on transformer attention mechanism. So that is why these things will come in your picture, that okay, how responses are coming and how they are built on. Because once you have these basic systems, if you know it very well, you can easily justify this course, right? So these things that but just to make you aware very visually that where we stand, right? AI, ML, and then we have something called, this NLP or deep learning, right? So we will follow like this only, okay? So coming to this again, how you do not get confused with this Gen AI and machine learning. So that is why I'm just showing you this, this machine learning here. I'm not dragging you to GenAI and Agentic AI right now. Slowly, I'll switch to GenAI and Agentic AI. But first, my idea here is to make you aware about this machine learning part, because Once you are aware of this machine learning part, then you are good to go to GenAI and agentic AI. Then you can easily switch. It's like a put a a kind of autopilot mode, and then you'll understand. Okay, so something which I want to bring your attention here is when I talk about this machine learning, the few algorithms will come into play. The something that I was talking about is regression, classifications, right? Clustering, associations that you can talk about, right? So you might have heard of these terms, right? In few of the courses might you have gone through where you might have seen how to do cluster, what is market basket analysis, or association rule minings. So, okay. And classification regressions, you might have seen or created some other project around predictions, right? Maybe the stock predictions or something, right? You might have seen something called classifications, right? I mean, these are the few algorithms that you might have aware of, but these all are built on historical data that you have to understand. Just think of, let's say, one of the big basket, let's say there is an organization and they have sales data for last 10 years. Okay. And they want to create some of the recommendation systems or machine learning algorithms. They want to forecast it that, let's say, XYG is my customer for let's 5 years. And whether they are my potential customers for XYG product or not, whether should I sell them to that person or not. So the historical data will help them to create a recommendations, something called personalized recommendations. Okay. So that will fall under this supervised learning where we have a labeled data. So the term supervised means what? Someone is, working under X person's supervision. Okay, you might have heard of. So supervised means a data will have some labels. So just make you aware of, just let me give you one example. So you see, you go in any market, okay? Have you seen labels on Coca-Cola, right? So every single product has their labels, and you identify with their labels that okay, this is Coca-Cola, okay? So you will have seen labels attached to it. You will see their logos, right? So that product is labeled. So the same thing, machine learning, where if you want to build any of the supervised learning model, you have to expose a data which are labeled. Means you'll have input and output associated with that data. Let's say if rainfall, let's say sales of 12 months. So month one is let's say 10 crore, month two is 30, 40, 50 something. Okay. So also there is a month and there is a sales volume. Okay. So this is one input and there is a one output. Okay. So this is how you can map. So supervised learning will have a data which are labeled, which are input output. Just understand at the high level. Okay. But unsupervised, the learning where we will not find any of the data labeled. It's like it's like a garage or a warehouse. You have every single things thrown. It's not organized. Okay, that we can think of it as unsupervised. Things are there but are unorganized. It's a thrown. It's like a garbage. Okay. But when you think of supervised learning, again, let me talk about this data where it is organized. I mean, it means a warehouse where things are put in place with data labeled. You might have seen warehouse of Amazons where every cartons have something labeled. So people can easily pick things from there because it's labeled and quickly people can access it, right? But when we have a data thrown like a garbage, it's very difficult to organize it, right? So that will fall under unsupervised learning. Okay. So when we talk about this supervised, again, I was talking about the input and output, but unsupervised one, we do not have any data. Okay. Now let me connect it with LLMs. Okay. Let's say you have a generative, let's say chatbot. So this is also unsupervised learning. How? because you are just putting a prompt and then it is giving you a response. Let's say if you are asking ChatGPT, give me, give me the details of Paris tourism. So they will give you the list of the places where you can go in a Paris and a list of hotels, maybe give you a lot of details. But how come they are giving you? The data is not organized. Data is not labeled. They are unsupervised one. A lot of corpus are thrown inside this LLM. You don't know how LLMs are trained. Okay. So the prompt here, the prompt is passing through the model and then it is giving a response. So LLMs are basically built like this, unsupervised. But majority of the machine learning, you'll see the architectures are based like this, where you'll see input data and you have some of the data output is there, expected output. Okay. But how you're going to, create. So you have to create a model. So you have some of the training data here that I was just talking about. So machine learning models will have a data where you have a training data first. Okay. Then you work on the unseen data. Unseen means model has not seen it before. So now, for example, sales volume. Let's say there is one organizations, they have 24 months data, okay, previous data, but they want to predict it for 25th month. It means a model which are built on 24 months haven't seen 25th month's data. Okay, that we call it the unseen data or test data. Test data means your model has not seen this data before. So people may use this term interchangeably, unseen data and test data. Okay, that is not part of the training of the data where you have used it in building those models. Okay. Now, coming to this deep learning. Okay, there is two terms that we were talking about. Is generative AI, right? I was talking about this generative AI also. So what is so special about generative AI that everybody is after this Gen AI, Gen AI? What is so special about, right? Because we don't need to train our data from model from scratch. So when you start building your model from the scratch, so you need to have a lot of people involved, a lot of GPUs, CPUs involved, a lot of manpower, a lot of dollars that you involve to train, right? So why not to bring in the pre-trained model so that it solve our problem? Every time you don't need to train it, because the reason for it is that also data will change. For example, our organization has built a model based on the historical data. So history will change because the new data will add. Right. So every time they're gonna build a new model, they will say machine learning model, let's say for version 1. And again, next year they'll have to work on version 2. Next year again version 3. How long they will be keeping training this model? So just to eliminate those gaps, this LLM has eliminated the concept of machine learning, training the model from the scratch. Okay. So when we talk about generative, if you see there are two layers here. So generating new data that is similar to data it was trained on, understand distribution of a data and how likely a given sample is, and predict next word in a sequence. So the something that I just want to highlight, LLM doesn't do anything. LLM does a prediction of a next word. They predict the next token. That's all. So whenever you ask, let's say if you're asking what is the capital of India, so it will give you Delhi. So what they are doing, they are just predicting the new token, next token. That's all. Coming from whatever data they are trained on. So when they start giving you tokens wise tokens, then you see entire summary of result, entire responses. So responses coming from any of the chatbot is nothing but is collection of next tokens. Okay, it's a next tokens. So just think of LLM response as a next tokens. Just remember it. LLM response are nothing but a collection of next tokens. Okay, predicting next tokens is the outcome of any LLMs. Okay, but the one more term is there on my screen, a discriminative. What is so discriminative about discriminative? Why not generative? The two term is there, generative and discriminative. Okay. So what till now I talked about the machine learning, till machine learning. It's a discriminative AI. Okay. So the word discriminative is again offensive, right? In our real world. But when we talk about discriminative and generative, right? So just think of it, because in interview they may ask you generative and discriminative. There are some smart interviewer, right? So can you explain me what is a discriminative AI? So discriminative AI is nothing but the classical AI, the machine learning that I was talking about. So what it does, it classify or predict. For example, we were talking about the classification and regression thing, like different machine learning model, logistic regression, decision tree, random forest that we were talking about. Okay, so these are the something that we were talking about. Okay, typically trained on a data set, labeled data. Again, it's machine learning, right? Learns the relationship between the feature of the data and the label. So feature and target, there is a one more word. So it's not like always we talk about input and output when we talk about the machine learning model, because data are like input and output. We feed to machine learning model, but it's we could typically call that a feature and labels. Now let me give you an example. When you apply for loan, so they ask you a lot of questions. Let's say 10 to 15 questions they ask you. What? For ICICI Bank, it is nothing but they are collecting features from you, because they have some of the machine learning model trained, and they will input these features to that trained model. And once they feed these features to their models, the model will give the predictions that okay, you are eligible for 20 lakhs loan, right? So that they call it as a feature. And the target is that you are qualified for these loans. So it is again a classifications. You have been given a loan, yes or no, right? So the again it is a feature. So ICICI Bank is collecting 10 to 12 features so that they can pass it into their model, and then they will classify whether you are eligible for loan or not. So it is again a discriminative AI. But the session for today is GenAI and agentic AI. Okay, it's a generative AI. Okay. Any questions so far? Any question? Anybody? Any questions so far? So let's have 10 minutes breaks and then we'll come back. Is it okay? Santanu sir is here.
Yes, yes, we can have a break for 10 minutes. And
Um,
students, you can post your queries in the mailbox also and be participative as I have told you.
okay, let's
All
have a
right.
10 minutes break and then I'll come back. Okay, so let's map 3, I think 6:40. 6:40. Okay.
All right. So we'll have a 10 minutes break. Thank you.
interact with you, and they give you a response like a human response. So don't you think it is like something kind of automations that they are automating it, isn't it? Right? So things which are very frequently, the need for this natural language is to give like a human, like user experience. At every industry, you will see some of the bots they are replacing, but they are AI bots, so that you feel like some humans are talking, right? Again, the foundation models, nothing but again LLMs they talk about. So OpenAI has a foundation models. Don't get confused with LLMs and foundation models. The base models they are talking about. For example, OpenAI has these GPTs models. Uh, Anthropic has a Claude models. You might have heard of this Claude Code or Claude models. Also have a Grok, some of the models by, I think, Elon Musk, the Grok. And so these are nothing but the foundation models they talk about, because they have built from the scratch, and now you can use it for inference purpose. The term I'm using is inference. What do you mean by inference? Inference means something which uh, you want your LLM to give. For example, if you want a new content to be generated, like a summarizing the new content, okay, question answering. So these are inference tasks. You are telling your LLM to do like this. If I give you some, a piece of a paper, just summarize it for me, right? So these are inferential tasks. We'll also work on this. A generative AI that we were talking about. So, I mean, again, generating new artifacts from existing artifacts, or something called we call it a Gen AI. So whenever something generating is what? A new content, something which are not available on the internet, something which are new. Every time you'll see the new content. Okay. So there comes, these concepts which we'll talk about, where we'll have all these things will follow, right? Gen AI, foundation models, LLMs, some of the AI assistants. So ChatGPT is one of the AI assistant, but we'll also have many more now. Okay. So these things which will come into play, but let me show you something which are very interesting. So so that we'll have something to uh, something which also you can work. So let me share where I was. Okay. So once my screen is visible, do let me know. Let me share my screen and this one. Okay. So hope my screen is visible, isn't it? Okay. So if you see here, so something which I was just trying to explain. There is one platform called Hugging Face. Okay, so the concepts which I have explained is enough, and that can connect the dots. And just I want something which is very interesting, and will keep using this platform entire journey for building our capstone project, small projects, the labs and all that. So the applications where we'll interact with, where different small language models, large language models. We have a lot of models which are commonly built by people who, and also commit it here. They expose it here, and people can use it. So more of a research purpose. So researchers do research and create their own models, pre-trained models, and use it for people to use, right? So this Hugging Face, if you can open it, so you'll see the interface like this. So it's more of a smiley logo, where you can identify this Hugging Face. So a lot of models there. It's like a one huge platform. So you can do a lot of research, and people like you, I think it's like a one of the finest place where you can learn generative AI and agentic AI, machine learning, NLP, something which you cannot imagine it is there here. So, I mean, if you start exploring this, it is good for you. Okay. So now what I'm trying to make you aware of, if you see, a lot of things are there on this screen. So let me scroll down a bit. So this Hugging Face looks like this. So you'll see a models. Okay, I'll explain. I'll also show you there is something called a spaces. I mean, we have some data sets. So for example, these all data sets are pre-trained data sets. So where we have some models inside that, the data set is there. A spaces is a place where you deploy your model so that you can test it that how your Gen AI or agentic AI solutions uh, are consumed. For example, if I click it here, this one, generate a three Gaussian model. So I'll show you, so don't worry. So these are the things we'll see on the screen of Hugging Face. So a lot of contributors are there, a lot of research paper you can see. Something which are very interesting, this platform. So I'll expect you to explore these. Again, it will give you a lot of informations which are again now open source, and we'll see a lot of organizations, enterprise, they have committed their models here. So a lot of things are there. So okay, just try to explore it. So now let me come back to a screen where I just wanted. So let me click it to this. Okay. So if I click it here, so you'll see in the left side, there is something called main task. Let's see, libraries, language, licenses. Okay. So a lot of things are there. And also, if you see, if I go down, you have something called text generations, image to text. If you want to do something called image to text, image to image, if you want to create text to image, text to video is also there, text to speech if you want to create. Okay, so let me go down. So a lot of libraries that you feel like start working on, for example, deep learning transformer, PyTorch is there. Okay, so a lot of models, libraries, Python, you'll see the Python libraries, some of the apps which you can use it. Okay, VLLMs, LM Studios, Olama is there also. You'll start exploring in few couple of the sessions. And some of the LLMs providers. So who all provides LLMs? Grok, Novitas, Sama, Nova, Nescaler. I don't know how. There are many more. Okay. So these are the things which you see. Now, coming to this models part. So you see these are the pre-trained models. So let me uh, just hit this one. This is image to text model. Okay. So what this pre-trained model is going to, this will fall under small language model. Okay. So if I click it, so this is the model, pre-trained model, you can say URL, so to say, we'll pass it. So I'll show you that how they have used it in the Python code. So if you go down, so on the right side, you see how many downloads. So it is like open source and you can use it in your Python script. Okay. So this model is image to text. So whatever in your image, let's say you uploaded one image and you just want to understand what this image talks about. So if you go by the machine learning models, then you have to have those samples of images ready first. Let's say at least 100 to 200 images. It's not possible to have those images and the older images also to train the model, and then show them the new images, and then you get a response back. It's very vague and weird for us. So why not, if something which are already trained, that we can use it, okay, and it can solve our purpose of training those models. So it is because it is a pre-trained. So if I go down a bit down, you see a lot of things about these pre-trained models. Okay, this is again a small one. So you'll see this is a multi-model, a term called multi-model. Multi-model means something which give you a more modality. For example, Chat GPT, if you're asking, to generate a new image, they will generate a new image. If you ask them to generate a new content, they will generate a new content, right? So they are multi-model, more than one model, more than addressing a one modality. Okay. So you'll see a lot of things, and just you just try to read it out. Okay. And these are the specification about this pre-trained model. So it is supporting two modality. It can generate text to text and text to image. Have the sliding window, 1024 tokens. What does it mean? It means your LLM or a small language model can process 1024 number of tokens. For example, we all humans can process, let's say, 100 words. So we can process 100 tokens. But LLM can process 1024, 1024 tokens. Words they can understand at one time. Okay. So also these tokens that we can pass, there is something called canvasness, vocabulary size. There are a lot of things is about this pre-trained model. Okay. And it is also benchmarking that parallel to these models, what are the accuracy of the models which are the competitors. Okay. So if I go down, so we have these capabilities, few of the capabilities of this pre-trained model. So Gamma handles a broad range of tasks across task and visions. So they can handle the image. Okay, so these are the specifications, details. Okay. Now, this is the Python script. Okay, so if you have Google Colab. So in the Google Colab, what you can do, you go to this model or any of the models and start putting this in a Google Colab and a sequential manner. So this is our libraries. Okay, you manage humans universal. So you have these libraries. You have to install it, and then you put these things. Now, if you see this model ID, directly they are using it. So this is our pre-trained models that we were talking about that will convert image to text. Okay. And these are the some, how you are going to load the models. So ID, auto, device map, in the Python script. Okay. And if you pass this prompt, because whenever you have any of the small language model, if you are passing that, why is this sky blue, let's say. So they will process the input here. If you see this one, processing the input. Input is why this sky blue. Okay. So this will process the entire input here and save the output in output. Okay. The maximum tokens they have this is 520. And once they have this output, input processed in the output, then they will parse it the output because we will not understand the output. So need to parse it so that the human can understand. So that is why this parse content is there. Okay. So then you will see some of the output in our screen. Okay. Because of the parsing part. If you remove this one, will not have these things in the numbers you will see in the screen. Okay. So the Python script, I would say you just use this Google Colab and start using this and you'll see the output. Okay. And I will also show you in coming sessions that how we can use these pre-trained models. Okay. The idea here is to show you something which are, you can say the something which are very basic one where you can start exploring this Gen AI and agentic AI concepts. And this is one place where you can explore it. Okay. So a lot of models is there. Just think of these models. More than the 2 lakhs, I think. It's at the 29th lakh. Around 30 lakhs models are there. Just think of. If you have some data set, let's say you don't have a data sets, you can pull in these data sets. Okay, a lot of just see data sets. Columns are there, title and summary is there, stored here. Okay, just see a lot of data is there. Okay, you can use it from here also, not from the Google Colab. That what we say, right? Now, let's use these spaces also to understand that how we can use these spaces, okay? So spaces are something that people have deployed their small language models, okay? So let's say something which, you can generate or something. There are a lot of things. If you see 3D chat with multi-model AI using text and image, so let me just click this one. I don't know this will work or not. So you'll see this interface like this. So this is deployed on Hugging Face only. Okay. So I want to wash a carpet and what should I do? Something like this. I'm just sending it. Just see whether this gives a reply or not. Okay. So this is, people have deployed their Gen AI solutions in, Hugging Face only. So also you people can create some of the pre-trained model and you can deploy it. Okay. So they are also just see they are giving us a response because it is a deployed. Okay. The same thing you can do it. Okay. So these spaces will help you quickly, understand that whether my applications are deployable or not, and you can quickly check the quality of the applications first, and then you can deploy it on a real server. Okay. For example, if you see any of the GenAI or agentic AI solutions, so once you build a logic, let's say if you are working on to create a chatbot, let's say small university chatbot that your university has asked you to create your departmental level chatbot. So now everybody will use it. Okay. So logic and everything you have created in local. Now you have to deploy it. How you will deploy it so that everybody can use it, right? So you need any of the cloud platform, right? So this Hugging Face is one of the cloud platform where you can also deploy your small applications, not a large applications, so to say, right? But if you want to deploy it a larger applications, also you have to take enterprise level editions of this Hugging Face. So they will give you, the spaces, storage, and everything so that you can deploy. But the ideal case is again to pick up any of the cloud. Okay. So I'm just giving you an idea that what cloud you can pick. So for example, if you have some Azure Cloud, AWS, okay, GCP, okay, these are the cloud that you can deploy. But again, I would suggest to in this course better to use the local deployment first, so that I'll also teach you that where how you can do this local deployment. So quickly up to that one is very, very, good for you that at least you can do that. Okay, so I will be teaching you also that how you can do this local deployment of your applications, GenAI and agentic AI applications. So it's very interesting that we'll start picking up few labs which will make you enterprise ready and put a lot of values to your resume so that you can start adding those use cases or GitHub also, and putting it in your resume so that you will be ready for any of the interviews. Okay. So I think I'm done with today, whatever I just wanted to present. And okay, so if you have any questions, I would love to take few questions, and then we'll meet in the next session. Okay. Anyone has any questions? So uh, if you have any questions, you start putting it so that I'll start answering. And from any of the sessions for last, these 5, 6 days, from any of the sessions you feel like that you didn't understand from any of the speakers. So I'm here to give you, the reply, response, whatever you call it. Okay. I can see a few questions. What I can see. Why do we need? Okay. So are you talking about explainable AI? Okay. So when we talk about this explainable AI, so for example, every single model is a black box. So, black box model are not interpretable and not explainable. Means when you use any neural network, so how they have come up with the decisions, how they have given you the response, we are not pretty much sure of. So for that, we need a layer of explainable AI. For example, there are a few libraries, Python libraries, or framework of explainable AI. So you might have heard of something called Line, SAP, uh, ELI5, GradCam, yeah, for the images and all that, CapTum. That I can recall a few of the, explainable AI. So I mean, there are many framework, and depending on your use case, let's say if it is text, then more of a, this ELF, and lines. If you have some classification, then people use line. Then we have a SAP, Sapely Additive explanation. So that is based on game theory. So there are many more explainable AI framework where you can use it, but you don't need to use it in Genia and agentic explainable AI, because to bring things on make them a grounding response, we have this RAG applications, tool calling, MCPs. Okay. So, I mean, these are the things that you can work on, but more of if you're working on any of the deep learning models, then you have to add this explainable AI layer to it, because without adding it, it's like you're not explaining your output. So yeah, that is required. Any more questions? Anybody have any questions? I have 2 more minutes so that I can give you a reply from any of the sessions that you feel like. Okay. I'm here, so you can ask. No questions? Okay. So let's close for today. Sandhu sir, are you there?
Yes, thank you, Mr. Satyajit. Thank you for your power-packed session. Hope we will see you again in next Saturday and Sunday. As usual, students will have Monday and Tuesday. Instead of Monday and Tuesday, we'll have it on Saturday and Sunday. So Mr. Satyajit will take it on that day. And in the meantime, your materials, slides, and other recordings will be put up by tomorrow. And still, you have any doubts or anything want to discuss, any queries you want to, do you think it should be discussed? Put it in the group also. Thank you. Thank you, everyone.